Welcome. Let's see differential feeder protection, in respect of transmission line, distribution line. Symbol representation of differential protection. As per IEC 60617 it is denoted as ID. As per ANSI it is denoted as 87. Here we will see principle of differential protection. It works on the basic principle of Kirchhoff's current law, that compares incoming and outgoing current of feeders. In case of healthy system, there should not be current different, or in other words current should match. Current transformer would be required as a input to differential relay for current measurement. Current magnitude should be accurate, so we are using protection X class CTs. Now let's assume busbar fault has occurred at station B. Here the fault current would flow from station A to station B. Fault is getting feed to load through overhead line. This is called through fault condition. In this fault condition current IA and IB would be same, so there will not be any tripping of line. Now let's assume fault at middle of line. Here the fault current would flow from station A to fault location. Fault is getting feed up to fault location through overhead line by source. In this fault condition current IA would be greater than IB, so due to current magnitude difference, relay will pick up and trip the breaker. Position of current transformer at both ends define protection zone. Differential relays have good operating time, which is less than 20 milliseconds. Distance relay is also faster relay, but it operates in predefined zone of protection that is 80% of line length. Overcurrent relay operating time is greater than 500 milliseconds, due to its current characteristics. Main 1 protection is considered as differential protection, and main 2 protection is distance protection. Both shall have different communication line and separate core for input from instrument transformer. For the short length of transmission line, which is about 200 meter, we could provide single relay for feeder protection. For the distance greater than 200 m, it will not be feasible to connect wire direct to relay. Due to higher length, we need to increase size of conductor, to reduce resistance of wire from CT to relay. So, we need to consider separate relay at each, for distance greater than 200 m. As explained in previous slide, in case of distance more than 200 meter, we need to consider dedicated communication link between differential relays, which could be either through metallic pilot wire or fiber pilot wire or optical ground wire, OPGW. In this pilot wire scheme, pilot wire is used as a metallic or copper wire. Instead of metallic pilot wire, fiber pilot can also be used. Now relays are available to use fiber optic links. In this scheme, current transformers are connected with summation transformer, which in turn further connected to relay, through insulating transformer. Insulating transformer is used to avoid voltage transfer, in case of ground fault in either or substation. Summation transformer will generate voltage, and relay will monitor the voltage vector. In case of fault at F2, there will be potential difference between VA and VB, and relay will operate at both ends. In case of pilot wires open or short circuit, relay input will become unbalanced, and trip the breaker. To avoid this, health monitoring of pilot wires is required. For this relay inject current into the pilot wire, and monitor its presence at remote end. This methodology will vary manufacturer to manufacturer. Some relay may use high-frequency voltage to monitor status of pilot wires, so the relay operation is blocked, in case of open or short circuit of pilot wire. In this differential protection scheme, R phase, Y phase, B phase, current transformer phases are in parallel, then it is fed to relay. These combined currents are monitored at remote end. If current will not match at both ends, relay will give trip command to breaker. This scheme is used in transmission and distribution feeders. In case of fault, voltage input to relay will be unbalanced and it will give trip command to breaker. Thank you for your attention and time. More stuff coming soon. Don't forget to subscribe.